Hey guys, my name is Darkwater Killer, and I hope you're having a wonderful day. Today I will be starting a series that covers digital electronics. If you don't know, digital electronics is a part of computer science and computer engineering that pertains to combinational logic circuits. More on that in a second. To help teach this, I'll be using a lightly modded version of Minecraft as a medium. This is just to make things easier on myself and keep the videos from becoming too long. I also want to preface that this is not a how-to redstone series. The reason I am using Minecraft as a medium is because redstone and combinational logic are very similar in nature, and you can actually use redstone for combinational logic. However, the purpose of this series is, again, to go over the fundamentals and give you guys a basic understanding of digital electronics. So anyway, combinational logic, what is it? Combinational logic in its most basic form is taking a list of inputs and outputs and using that list to create a circuit out of logic gates. In this episode, I'll go over some of the terminology and the 7 most basic logic gates there are in combinational logic. Everything in digital electronics is always going to be in either one of two states, high or low. This can be represented as a 1 or a 0. And think of it as when you're using a light switch. When you turn your lights on, you're setting the signal high or you're giving a signal of 1, and so the lights turn on. And then when you turn the lights off, you're setting the signal low, which means that basically that outputs a 0 and the lights turn off. So the next bit of terminology is just going over what a truth table is. So over here on this monitor, I have just a program that I can just click on any of these truth tables and it will display that. So the first truth table will be the truth table for a NOT gate. And so here on the left, I just have the inputs, and for a NOT gate, the inputs are, there's only a single input, and that can be either a 0 or a 1. And on the right side of this table, I have what the gate will output. So depending on what your input is, the NOT gate will output the opposite of that. And so inputting a 0 will output a 1, and inputting a 1 will output a 0. I can show you here. I have a NOT gate, and so the input side is here, and these three sides are outputs. I'm just going to output that to a light. So right now, the input is a 0. So the output is a 1, and the light turns on. But if I set the signal high and make the input a 1, the output will become 0, and the light shuts off. So the second basic logic gate is the OR gate, and the OR gate typically has two inputs. So over here I've got an input on the left and I have it set up for an input on the right. So these inputs are over here, and so you can have an input of 0, 0, 0, 1, 1, 0, or 1, 1. And what an OR gate does is if any of the inputs are high, so if any of the inputs are a 1, the output will be a 1. So the only time an OR gate won't output is when both inputs are set to 0, like it is now. So if I say I want to set it to 0, 1, 0, 1, the output is going to be high and the light turns on. And if I set it to 1, 0, the output goes high and that light should be on. And the light turns on. And then if both of them are on, it doesn't matter because even if just one input is high, the output will also be high. The next gate is the AND gate. So same deal as the OR gate. It's got two inputs. And these are all the possible configurations for those inputs. And an AND gate only outputs when both inputs are on. So when input A and input B are on, then the output will be high. So as you can see over here, both inputs are low, they're 0. If I only make one input on, the output is still low. And if I make the other one on, the output is still low. It's only when both outputs are high will both inputs, if both inputs are high, the output will be high as well. The next two gates are variations of the OR and AND gates. So they are the NOR gate and the NAND gate. And they're basically the same thing as the OR and AND gates, except their outputs are inverted. So it's as if you had an OR gate with a NOT gate on the end of it, inverting the output, or if you have an AND gate with a NOT gate on the output of it. So over here, I have the NOR gate, and as you can see, the output is high when either of these are low. And then if I make either of these inputs high, the output goes low, and it just, whenever there's any high input in the NOR gate, the output will go low. And then for the AND gate, I don't know why that is working like that. Okay. For the AND gate, the NAND gate, when both inputs are high, then the output will go low. So if either input is high, but the other one is still low, the output will stay high. It's not until both inputs go high that the output for the NAND gate will go low. So it's just like if you were to put in inverter or not an inverter, a NOT gate on the end of like an OR gate, like this. It's the same concept. This is basically what a NOR gate is doing. The final two logic gates are a little more complicated. They are the exclusive OR and the exclusive NOR, where it's written as XOR and XNOR, the X meaning exclusive. So the way these gates work is that an XOR gate will only output when a single input is high. So if it's either 0, 1, it'll output a 1, or if it's 1, 0, it'll output a 1. In any other case where the inputs are the exact same, so if it's 0, 0, or if it's 1, 1, then the output of the exclusive OR will be low. So I can show that by just putting down an XOR right here. And I'll just forget about the wires right now. So both inputs are the same. Both inputs are low. So as you can see, the levers say they are off, and that light is off. But when I set one of these inputs, when I set one of the inputs high, the lamp will turn on. And I can show you with the other one as well. So only one input is high, so the lamp will turn on. When both inputs are high, the lamp will turn off, and the lamp will also turn off when both inputs are low. So basically it's when the inputs don't match, the output will go high on an XOR. And in XNOR, or exclusive NOR, is the same thing as an XOR, except that it is like it has a NOT gate on the end of it. So it's basically how a NOR gate is the opposite of an OR gate, or how the NAND gate is the opposite of an AND gate. So as you can see, both inputs are the same, the output is high. When the inputs aren't the same, the output will go low. So they're the same again, high, and then they're not the same and the output is low again. So they're a little more complicated, but they're the last bit of the basic logic gates. So they're called the basic logic gates mainly because of the fact that all other combinational logic circuits are can be made out of these components, and if you want to get even further into it, some of these logic gates can be broken down further. It's just when we draw circuits down on paper, which I might show later on in this series, um, it's a lot easier to use things like the XOR, XNOR, and like these last four. It's a lot easier to use these instead of drawing, say, for example, an OR gate with a not on the end of it for a NOR. It's easier to just draw the symbol for NOR. So it saves space and it looks cleaner in the end. So that's why um, these are considered to be part of the basic gates. Okay, so that's all I have for you guys today. I hope you enjoyed the video. If you want to see more like this, let me know. Don't forget to leave a like or dislike. It doesn't really matter to me. I just want your feedback on what you guys think of me doing this series. Um, if you want to interact with me directly, consider joining my channel's Discord server. I'll have a link for that in the description below, as well as there should be a link over on my website, which is also linked below, and you should be seeing um, the URL for my website on the screen around now-ish, if I remember to do that in post. And over there on my website, you can go there and download any of like the data packs that I've shown in my other videos, and it's got links to my Discord, YouTube, Twitch, that stuff. So that's where most of my stuff will be uploaded to from now on. Most of my downloadables will be uploaded to. I'll still be posting up here on YouTube. So that's pretty much it. My name is Darkwater Killer, and I hope you guys have an amazing day.